And in this video, we're going to cover kind of the second half or second strategy for active techniques, and that is generating energy. We're talking about local renewable power generation, so local typically on your building site. And this is usually needed in order to meet your net zero energy or your carbon neutral design goals. There's many sources of power generation, and we're going to cover some of the most common. Starting with photovoltaics, abbreviated PV. All right, photovoltaics are equipment that converts light to electricity. They're typically installed, you've seen them around town, as angled arrays of glass-covered rectangles. All right, and they can be located on rooftops or next to your building. I've even seen them over parking areas. The advantage of photovoltaic systems is that they are renewable energy. They're decentralized, available everywhere. There's sun pretty much everywhere, all right? And you can use net metering, which means that you can sell any extra energy back to your power company often. The disadvantages are that photovoltaic equipment generates DC or direct current power. Therefore, you're going to need an extra equipment, a converter or a transformer. And also, you don't get any power during the night or during cloudy days. All right. So it's important to have a backup system. In general, peak demand for energy, for power, occurs on hot, sunny weekdays. All right. And that's when air conditioning systems are going to strain the power grid. Luckily, it's also when photovoltaic panels perform at their best. One way that you can run your PV system is to tie it to the power grid. Therefore, it will add to the power network, all right, your municipal network, when it's needed the most. But this is your backup system, like I just said in the last slide. It's going to draw from the grid during off-peak periods, all right? So when it's cloudy, when it's nighttime, and there's typically excess capacity in the grid at that point, and power is cheaper. This is a major benefit of PV systems. They will flatten the daily power demand, all right, and allow your grid, the municipal power grid, all right, to operate more efficiently. We can use solar energy another way to help with energy efficiency, and that is with solar hot water. Now, this strategy doesn't actually generate any energy, all right? It doesn't generate electricity, but it uses solar power to reduce total energy requirements, and that's why we're talking about it here now. Solar hot water is one of the older and more mature technologies of the ones that we're discussing today. And it works by circulating fluid, it's typically water, all right, through some heat absorbent tubes that's going to be heated up by the sunlight. And then you use that either directly for hot water, you know, for your shower or for your pool or for your dishwasher, all right? Or you can use that hot water, blow air across it, and use it for space heating in your building. Solar hot water systems come in two varieties, two flavors here. On the left, you see an open system. All right, in this case, the fluid in the hot water system is just regular potable water, and it's used directly for the plumbing or very typically for heating a pool. On the right, we have a little bit different. It's a closed or indirect system. And this one, the fluid that's in the solar hot water system is typically going to contain antifreeze. And so it will run in a separate or indirect system. All right, and then we transfer the heat to the potable water system in your plumbing or to blow air across it for a heating system in the building. Our next way to generate energy is using the wind. Now, you might be most familiar with wind farms, and these are big. They're the wide blade turbines, and they're on hilltops or next to the ocean. All right, and they are highly efficient. They can produce energy at the same cost as conventional energy production plants. All right. But when we're talking about generating power on site, on a building site, what we're talking about is distributed wind power. All right, these are smaller wind turbines and they're mounted on or next to your buildings. Unfortunately, these may or may not be cost effective. All right, it's actually hard to get the wind turbines to perform well on buildings, although the technology continues to improve. Let's dig into qualities of wind energy in general. The first thing you need to know about it is that it is intermittent. Sometimes the wind blows, sometimes it doesn't. All right. This isn't a problem if your building is tied into the general energy grid or combined with other sources. It's a little bit of a problem for a standalone system. All right. For wind energy, the local conditions, the microclimate, all right, is critical. And so we typically put them on mountaintops, mountain passes, and along shorelines. Wind energy requires smooth airflow. And so urban areas sometimes are a problem, all right, because the buildings produce choppy airflow as the wind goes through them. Our last topic I'm going to cover in this video is geothermal. Geothermal energy is, that's the name for heat from the earth. And there's two different ways that we can take advantage of it. The first one is geothermal heat pumps. All right. Like the solar hot water systems that we saw before, these don't actually generate energy. All right. They don't generate electricity. But they use solar power to reduce the total energy requirements for your building, all right? And therefore, we're talking about it in this category. The heat pumps are going to take advantage of the constant temperature of the earth to become part of the heating and cooling system of your building. The other major way to use geothermal energy is typically not for an individual building. All right, it's more for a municipality, and that is a geothermal power plant, and they'll use steam to produce electricity. Let's talk a little bit more about those geothermal heat pumps. They are very popular in green design here because they use much less energy than conventional heating and cooling systems. So how do they work? Well, it turns out that although the ground level of the Earth heats up and cools down with the weather and the time of year, all right, once you get a couple of feet below, the temperature is relatively consistent and it's warmer than the air in the winter and cooler than the air in the summer. We can take advantage of this, all right, by exchanging heat with the Earth using a ground heat exchanger. What's that? It's a system of pipes. And we call it a loop because the water travels in a loop through it. All right, so that's the name. And the pipes are buried next to the building in the ground. All right, as fluid circulates through the pipes, it will absorb heat or give it up, depending on the time of year, all right, from the ground. And that's how this works. Thanks, everyone. In our discussion of active techniques for energy efficiency, this video covered different ways to generate energy on site.